So I hope you got that. Now, let's go and do some actual calculation of GPE. All right. If you look at my calculation here, it's quite simple. GPE is equal to the negative work done on the mass. Why is it negative work? Simply, as we just explained, GPE by nature is negative, because it's quite clear just then. Now, work done is equal force times S, displacement. Force is the force due to gravitation, and this force follows Newton's law of gravitation. Okay, so Newton dictates that the force between two bodies under gravitational effect is big G times m, big M, big little m on r squared. Now the distance that you move will be the distance that will be referenced to the center of the Earth. So r is not from here to here. In fact, r is all the way from measured all the way from the center of the Earth. Okay, so if you put it all together, you will get GPE to be minus G big M little m on r, where big M is the mass of the planet and little m is the mass of the object. Okay, nice and easy. I hope you understand that. Now, to get a clearer picture, we shall then look at the graph of GPE versus distance. The best way to look at it is put the Earth down here, our vertical axis. The Earth, let's assume the Earth is the origin point. The GPE on the y-axis, the positive y-axis shall represent positive GPE, the negative y-axis shall represent negative GPE, and the x-axis shall be used to represent the distance of an object away from the surface for now. Now, you see here on the graph, big R here is the value of the distance from the center to the surface, which is the radius of the Earth. So if we graph this carefully, we should realize the nature of GPE dictates that GPE can only be negative. Now, if an object is placed on the surface as shown here, that means there should be a particular value for GPE at that point. Remember what I said to you earlier? If we dug a hole, if somebody had dug a hole 100 meters deep in the Earth, then there's a smaller GPE again down there. So let's assume that the object starts from the surface of the Earth. At that point, because its distance is r units away, using the formula above, as you can see, it's G m big M times little m on little r, but in this case little r is equal to the big R, the radius of the Earth. So we can calculate the value of GPE of a body that is resting on the surface of the Earth using that value. So I guess it doesn't really make sense if we try to understand the value GPE of objects inside the Earth anywhere at this point. Now, as we said before, if we increase the distance r, so if we move the object along that line across to the right as such, the value of GPE should be increasing, but it's increasing towards what? It's increasing towards 0. There's 0 up there. So when you plot it at that position, its value should be here, right? At that position, its value should be here. Can you see that at that point? So let's call this point 1, point 2. Can you see point 1 will have a smaller GPE than point 2 because it is not as high, the altitude is not as high as point 2. Now, if I keep on moving, say, from point 1 to point 2 and then all the way to infinity, if we can get to infinity, then the value GPE of that object shall be 0 as we dictated. And if you look at it carefully, the formula for GPE is this. It's G, big M, little m on little r, the distance away from the center of the Earth. And we have here, what we have here is a graph which is pretty much hyperbolic. And if you look at this carefully, if I let this be y and r be x, so GPE be y and r be x, because r represent here the x-axis and this is the y-axis. Can you see that big G and big M and little m are all constant? You cannot change the mass of a body. Likewise, the big G is a universal gravitational constant. So this equation will look like this. Y is equal to K on X. And that, in mathematics, is a hyperbola. Okay? So that's it, guys. I hope you understand and enjoy your homework. Lots of questions here. So, see you in class next week.